Hello and welcome to this RMAN Backup Recovery trailer for the RMAN Backup Recovery course. My name's John Boyle and I'm based in Manchester in the United Kingdom. I've had over 30 years experience in IT, 11 of those years were in IT management. The last 15 years I've been in training consultancy, predominantly on the Oracle database. 6 of those years I spent working as an employee for the Oracle University in the UK. Provided training courses throughout the UK and Ireland. Within Europe, notable events were Paris, Brussels, Utrecht, Milan and Helsinki. And over to the USA, been to Tampa, Monroe, Memphis, Chicago, Minneapolis and also taught in Madison. I've also been to the Oracle head office, the HQ, in San Francisco for the Oracle Leadership Circle. So the RMAN Backup Recovery course does actually cover Oracle 11G Release 2 and 12C Release 1, and it's been a course specifically written to combine those two releases. So what I'm going to do for you today is a short introduction and then provide a couple of demonstrations to you. One, very simple, cold RMAN consistent backup, and the second one is slightly more complicated, but just to give you a feel for the amount of functionality that's within RMAN, a hot or inconsistent incremental backup. As I say, I've got two databases, so I'll switch between the two databases between those two backups. And then at the end of this, just to give you the course topics that are on the course proper. So if we look at what our current situation might be. Now what I've got here is a bar. Now across the bar from left to right is a timeline. Now, there's no scale on this, so this might be from beginning to end, it might be a month, it might be 3 months, it might be a week. But what we've got here in the red is when the database instance crashes, and in the blue we've got the amount of time for recovery. Now the red may simply be an instance crash, so it may just be nothing else is affected but our instance has failed. In that case, hopefully all we need to do is restart the Oracle instance, but there's still some recovery time in restarting the instance, because apart from doing instance recovery on the data files, Oracle's got to open all the files and things like that. So there's still some recovery time. However, the crash may have been to do with, for instance, a media failure within the Oracle database. Now in that case, where I've lost a data file potentially, I can't just do instance recovery, because it would fail. So what I've got to do in that case is restore and recover. To restore and recover any corrupt or missing data files, and then I can do the instance recovery. So recovery is two things in that case. It's media recovery, then instance recovery. But it's still a time scale. But what I need to do is address the first point is this recovery time. Can I improve it? Either the instance recovery or the media recovery times or both. So what we've done here is the second bar is now the current situation, and that's better because you can see there's a lot more green, which is system availability. So what we've actually done between the first bar and the second bar is we've reduced the time that the recovery takes. Now that will be two parts again. It can be the instance recovery, which we optimize, or it can be the media recovery, which we optimize. Just an example of media recovery we optimize. If we're now, for instance, on a Thursday, and the database backup we took on a Sunday, if we've had a media failure, we've got to do a restore from the Sunday. And then we've got to do a recovery of all Monday, Tuesday, Wednesday, Thursdays updates to the database. So that's 4 days worth of rolling forward we need to do. Where if I did have a backup from last night and I have the same media failure, I restore the data file or data files from last night. So that's the restore phase. Then the recovery phase is just rolling forward to days rather than 4 days. So it's rolling forward 1 day. So that will make the recovery time shorter. So that will, in effect, decrease or minimize the MTTR. MTTR is mean time to recover. And in plain English, it's reducing the size of the blue entries, which gives me a benefit because it's increased the availability of the system. Better still is if I attack the crashes. And if we again compare this third line to the first line, what I've done is I've eliminated that crash somehow. I've eliminated the third crash somehow. So if you look at the green now, there's a lot more green, a lot more system availability than the first one. Eliminating crashes eliminated the recovery times needed for that crash. So now compared to the first one, the third one Again, a lot more greens. So what we've done there is increase or maximise what we call the mean time between failures. So we've now only got 2 failures. The mean time between failures we've increased. And in English again, it's reducing the number of red entries. So 3 is again better than 1. So taking that a little further, that's the best solution so far. We've got to do both. That's the optimum situation. So here on this 4th entry, if we can again compare that to the first entry, we've maximised the mean time between failures. There are less failures, less reds, and we have at the same time minimised the MTTR, i.e. the blues after we did have a red failure, they're shortened. So compare the first bar with the last bar, that's the ideal situation for this particular database. Or is it? What we've got to know from the company's representatives, the people who are in charge of the company, people responsible to the stakeholders or shareholders, is what is the cost of loss of service? Now I've put the cost in quotes because I can't quantify that cost because it's a business decision. If we don't have a system for 2 hours, what is it going to cost? It could be in terms of credibility, lost orders, but what is the cost of the loss of service? So if I look at this graph, on the x-axis I've got time. Again, I haven't put any timescales on this, and on the y-axis I've got the cost. So before point A, the database was okay. There was no cost of loss of service. Now at point A, that is when my instance crashes, not up to us. But there is a certain cost. And this seems to me to be just indicating an instance failure, because we know how long it will take the instance to recover, so we should know how long, therefore how much an instance crash will cost us. Now once we get to B, if we still haven't rectified the problem, you see the cost is going up. That tells me it's probably now a media failure. So that cost is me restoring and recovering the data files. Now obviously that's a lot more cost, and for every moment of time, every unit of time that goes up, the cost is going up. Once we get to point C, it's now getting critical. Point C to point D, the cost is going up exponentially again. So I've got to know again, what is the cost of D? Because something else has happened between C and D, and that's cost my organisation far too much money. So I've really got to eliminate that one completely. What I want to do is reduce C to B. That's reducing the mean time to recover. And I've got to make sure I've understood what's happening between D and C and why there's extra cost there now. I think if we got to point E, I think that's indicating to us we should give up, because the time has stood still now, but the cost is going up, and I think that means your business has gone out of business. So what we have is a service level agreement. If you remember that graph, let's go back to that. This is our 4th bar, is our best solution so far. What we've got to understand now is that's the best we can do, we think, but is that still okay as far as the company's survivability is concerned? So we come back to what we need to have is a service level agreement. Service level agreement must be business led. It's nothing we as IT people can formulate. What we need to do is quantifiable loss due to these outages. I've just given an example here. Maybe financial cost, maybe credibility with customers. What I don't want to do is go to the business leaders and say, look, think about financial costs, think about credibility with customers, because they've got to come up with it. They've got to start with a blank piece of paper and say, look, if we don't have a system for X amount of time, how much will it cost us? What are the consequences of it? However, once they've come up with what they think are the business-led quantifiable costs, we've got to have a look at that and understand that. And then we've got to say, okay, we accept that and we'll abide by that. If we can't accept it or we can't abide by it, like for instance, we've got too many failures that is outside the parameters of their service level agreement, we've got to do something about it or go back to them and say, look, we can't achieve that with the current configuration of the system. However, the other thing to make out when we're doing this service level agreement, it's really about the availability of the system. So that obviously includes application availability tolerances. The problem with application availability tolerances is the more we make the system available, i.e. the more we reduce the mean time to recover, that can affect performance. Just to give you a very simple example, if we're trying to reduce the amount of time the instance takes for recovery, one of the things we can do is make the database writer background process more aggressive. When a transaction commits, it writes to the online redo logs, the vectors, and writes a commit marker to the online redo logs. It doesn't necessarily at the moment update from the buffer cache to the data files, which is database writer's job. So in the event of a crash, an instance crash, That update that we've now done and now has been committed, it's in the redo log files, but it's not been applied to the database. So part of the instance recovery is updating the database files with those entries from the redo log to update the database to reflect that committed change. Now if we ask database writer to be more aggressive, i.e. more quickly write back from buffer cache to disk, in the event of a failure we'll have less instance recovery to do, less transactions to roll forward, so the instance recovery is quicker. However, if we make database writer too aggressive, that's going to simply adversely affect performance of the database, and that's not acceptable. And I think the rule here is good performance and acceptable recovery times. So we now go on to the recovery time objective, and for all identifiable failure, what we need to know is the options we have now got for recovery. We also need to know the complexity of the recovery operations. We must know what is the fastest option for recovery. What we need to know is how long the process will take. Don't forget we have this service level agreement, and very importantly as well is the recovery point objective. Recovery point objective is where do we want to recover up to. So let's say for instance we now decide catastrophic has gone wrong. We go back to a backup and we do a restore database. When we do the recover database, we are rolling it forward from that backup. Now hopefully what we want to do is restore it and recover it to the point of failure, which means every committed transaction will be replayed. Uncommitted transactions will be lost, but that's good. We don't want them, they're uncommitted. So where the recovery point objective is the actual point of failure, that's complete database recovery. However, there's some cases where we can't do that. One example of that is if we've got a system where in the online redo log groups we are not multiplexing the files, i.e. we've only got one redo log member in each redo log group. Now when a transaction commits, as we said before, what it does is write the change vectors to the online redo logs and the commit marker. Now if that's in the current online redo log and we lose that current online redo log, we have lost that was meant to be a permanent committed change. So in that case we'll have to do restore at the database level and roll forward with as much archive and online redo logs as we have available. But obviously we've got some missing now. So we have to stop at the beginning of where that redo log that's now missing was meant to have started. So that's a case where we're going to lose committed data. It's incomplete recovery. But we've got to know within our service level agreement, is that at all acceptable? So the conclusion here is the backup strategy must meet the requirements of the recovery strategy, which must meet the requirements of the service level agreement. Therefore, SLA is number one. It's the first thing we have to do. That will dictate our recovery strategy. And it's only when we've got an SLA and a recovery strategy that matches that SLA that we can actually evaluate and put in place a backup strategy which meets the recovery strategy, which meets the SLA. Okay, so what I'm going to do now is give you a demonstration on my 12C release 1 database of a simple or cold consistent backup. So what I've got here is a SQL prompt for my 12C which is a 12C release 1 database. I've done a shutdown immediate just for the purpose of this course, and then I've started up again, which is start the instance. So I've got a valid SP file, it's mounted the database, so my control files are okay, and database is opened, which means that S1 did any instance recovery. You'll also notice here, which is a good way to do it in SQL, is I've got a different prompt rather than just a SQL prompt, because what I'm doing here is displaying my user, then the as is any privileges I've got, and then the database identifier, the connection string. And you notice here there's a sys backup, because that is new to database 12C, and it's just an extension of Oracle's separation of duties. In 11G we used sys, which is sysdba, and that has too many privileges if all you want to do is backup and recovery. So all we've done with sys backup is a brand new role, and they are locked by default. They can't be dropped, but they should be used. So sys backup is purely and simply for backup and recovery, and we'll show you that in detail in the course. So what I want to do here, I'm doing a cold backup of this one, so I don't need to be in archive log mode. So if I just select log underscore mode from $database, you see I'm in no archive log mode. That's absolutely fine for cold backups, whether they're RMAN or user produced backups. My database is actually opened. An RMAN cold backup in no archive log mode, the database has got to be closed but mounted. Now, user managed backup, the database has got to be closed and down, not available at all. For RMAN to do any sort of backup, including a cold backup, it's got to read the database structure from the control files. So we do need it in mounted but closed mode. So what I'm going to do here is just shut it down again. Shut down immediate. Because it's got to be shut down in a controlled fashion. So what I need to do now is if I do a backup, an RMAN backup, where's the backup going to go by default? So I'm still in SQL. What I want to do is have a look at any parameters which begin with the string db recovery file. And there are two. db recovery file dest is the destination by default where my backups will go to. Now I can specify another location, but unless your recovery file dest is full or unavailable, then you should always let your backups default to there. The FRA is now called the fast recovery area. It is also called the fast recovery area in 11G. 11G release 1 and previous releases, it used to be called the flash recovery area. It's not exactly the same thing, but it's got a better name now, fast recovery area. And I've got the size of it, which is 6,930 meg in my size. Both those parameters are dynamic, so I can change those. And evidently it'll be up to us, once we understand the other things that are going in that fast recovery area, to keep an eye, to a degree, on the objects in there. Fortunately, RMAN will help us a lot with that. RMAN will do a lot of housekeeping in there. So I'm happy I know where they're going now. They're going to the right place. So I'm now ready to do my RMAN cold backup. My database is mounted, but closed. So what I've done there is connect to the target. I've used a different user because I've granted sys backup privilege to John, so I don't have to use sys backup. Again, you can use the password file or OS authentication, just the same as sysdba and syshopper were in previous releases. And it tells me I'm connected to target database, gives me the instance identifier, and then the database ID. I do need that in certain circumstances for some types of recovery. So the very simplest case, I can just say simply backup database. Now this looks very, very easy, and to a degree it is very, very easy. Okay, so that's now finished the backup. It looked very easy, it was very easy, but there are a heck of a lot more things to think about. But at least I've got a backup in my database now. See, I've opened the database from RMAN. Doesn't matter whether you do it from SQL or RMAN. For the second demonstration, I'm going to use Oracle Database 11G Release 2. Just the different database. It doesn't matter either way I've done this. They both would be exactly the same. What I'm going to do now is a hot, or what we call an inconsistent incremental backup. So a little bit more tricky. So I've got here a 11G SQL session. You see here I've still got the same prompt before, the user, the privilege and the connection string, and you see here in 11G I use sysdba to do backup and recovery because I haven't got the sys backup. Okay, so for a hot backup the database must be in archive log mode. So a useful command I've got is an archive log list. That tells me I'm in archive log mode. Another way of what I've got here now is an RMAN session for 11G Release 2 connected to my target database, which is the ORCL database. By default it's a sysdba connection, and I don't have a sys backup connection because that didn't come until 12C. Backup, we're now on incremental strategy, so they're incremental level 1. For recover of copy with tag, a tag is just a name that we associate between two incrementals which are part of the same incremental strategy. And I'm saying at the end it's going to be a database level copy. There, that's my incremental backup. Got all the data files. Those are not a problem. No parent backup or copy of data file found. It's just an information message, which I was expecting. So now I've done my first incremental backup. Now it was actually a level 0. A level 0 is a full database copy. I said incremental level 1. It won't do an incremental level 1, which is only change data blocks, unless it's first got an incremental level 0, the full backup. It's pointless doing a change data blocks if you can't apply them to anything. That's why I did incremental level 1. It's given me an incremental level 0, full one. So if I assume there's other work going on in the database now, and maybe we've had another 24 hours. So I do another backup incremental level 1, full recovery of copy, database. This is now, so that has now done my incremental level 1. So what I've now got is an incremental level 0, an incremental level 1. What I can actually do is apply that level 1, the changes, to the level 0 to make it up to date. So in effect, if I was doing recovery now, I'd have to restore the level 0, full database one, then I'd have to reapply every incremental level 1. However, what I can do before we have a problem is apply the level 1, the updates, to the level 0, bringing the level 0 up to date. So what I end up with is one level 0 which is now completely up to date. A lot of DBAs worry about this command to begin with because it says recover, and there's nothing wrong with my database. Recover copy of database with tag. That's why I gave it those tags. I'll give it the same tag now because I might have multiple incremental backup strategies. So what I'm saying here is recover copy of database with tag, the tag. So I'm saying find a level 0 if you've got one, which is the copy. Find any level 1s, which is the incremental, the changes since the level 0, and update with that incremental level 1, update that and put that over the level 0 to mean all I've got left with now is a level 0 that's up to date. It's a combination of the two backups. And I've now only got one level 0 backup. So that can be a useful strategy for us to use. Obviously everything that you've seen there will be explained in detail on the course, and there are plenty of other things in between those two backups. I've really gone from one extreme to maybe the other extreme. So just to give you a flavour of what the course topics are for the main course on RMAN, Backup and Recovery, for Oracle 11G and 12C. First of all, we'll be having a look at the strategies to extend what we've briefly described as the NTBF and the MTTR, and meeting the SLA, Service Level Agreements. Looking at the implications of the recovery point objective, i.e. if we have to do an incomplete backup, what are the consequences? Now the obvious consequence is we've lost data, which is not good. But these days, from 10.2 onwards, it's not as bad as it was within RMAN. We're having a look at the privileges for sys backup, which you've seen me use on 12C, that's 12C only. But you can still use this DBA on 12C, and 11G it's your only option. What we'll then be doing is proactive protection of your database instance. And proactive is far better than reactive. So if you can proactively make sure you're covered so certain things will not harm your database, then that's better than harming your database and fixing it. So let's have proactive protection of the control file, redo log files. Then we'll have a look at the FRA, the fast recovery area. Don't forget in documentation, if you see it being called the flash recovery area, that's fine. It hasn't changed, it just changed its name in 11G release 2. But not all publications and even Oracle documentation didn't reflect that straight away. We're having a look at a very important point, which is checkpointing of the database. Full checkpoints, partial checkpoints, and more interesting, I think, from either of those is incremental checkpointing. And then we'll go through on the course again, just preparing for and taking the first full database backup. Then we'll be identifying every single type of failure that we can think of, because if we are proactively going to attack this database from a backup recovery point of view, we've got to understand what could go wrong. So what happens and what do we do if we have statement failure, if we have process failure, if we have network failure? I'll leave user to the end, but if we have a program failure, maybe a PL SQL procedure, instance failure and media failure. Now this user failure is quite interesting. What it means is somebody could be on the command line and do something that they shouldn't be doing, like truncate table, and it's a table you really wanted. The other thing we've got to be careful of with users is sabotage of our systems, which is more frequent than will be made out because companies generally don't admit to it. We'll have a look at that as well. And then we'll be having a look in detail about the RMAN command line interface, the configuration settings, and commonly used RMAN commands and their syntax. And also at the end of the course I'll be giving you certain appendices which detail some of these. Then we'll be talking about the target, the optional recovery catalog database, and auxiliary databases. Those are the three types of database we can have within RMAN. Going on from that, we'll be having a look at backups in detail. Two types of backups within RMAN, copy or backup set, and two very different reasons for using them. We'll also be looking in detail about what we mean by consistent or inconsistent backups. And within incrementals, do we want cumulative or differential incrementals? And we'll be looking at a technique to speed up the taking of an incremental backup, which is often called block change tracking. Other options for the backup are multi-section backups. That is because when Oracle introduced these big file table spaces, the data file was too huge for RMAN to realistically back up. What we wanted to do is back it up in different RMAN sessions, so each backing up a different section of the data file. So that's multi-section. We'll be having to talk about encryption. Do you want your backups encrypted, particularly if they're going off-site? Duration and partial. You may have a window of maybe 2 hours each evening to do an RMAN backup, but if your whole backup takes 5 hours, then we've got to be into partial backups with duration. We can compress backups. Obviously those are backup sets, and compression can give us very good results. Not only is it smaller physically, but it can also be faster. Now a lot of people presume that because it's got to do the compression, it's going to be slower than a non-compressed backup. Well, actually in a lot of cases it's actually faster because of the less I/O it's got to write out, because it's compressed, so it can actually be quicker. Looking at the backup validate command, which doesn't actually back anything. Evidently, if we've done backups, we perhaps want to know how to restore and recover it. So we're looking at restore and recover at database level, tablespace or tablespace level, data file level. Now all those three are available in 11G release 2. New to 12C release 1 is we can restore and recover tables and table partitions. That's extremely useful. We'll have a look at backup and restore of the control file and SP file. We'll talk again about complete and incomplete recovery. And for incomplete recovery, we'll talk about point-in-time recovery of the database, table spaces, and again, just for 12C, release 1, point-in-time recovery we can now do at table level or partition level. I'll also be introducing you to the duplicate command within Oracle, which is extremely useful for testing, creating clone databases. Some people even use it for migration. Then we'll have a look at the 7 different types of flashback functionality within the database. Flashback database is obviously the main one that DBAs would use, but the other 6 flashback functions, things like flashback table or flashback transaction query, they all have their place and they can all be useful. And also the data recovery advisor, where we can go into RMAN, and if we've had any failure, we can simply issue the command list failure, then advise failure. And it can be very good, the data recovery advisor. Then I'll be giving you 3 sample scenarios. What I'll be showing you there is using and the syntax for the duplicate command. And then finally, what I'll be doing is demonstration of recovery of the loss of all of data files for the database, all the temp files, all the control files, and the SP file. Most important thing there is make sure you've got a backup first. Okay, so that's all I wanted to do in the trailer for the RMAN Backup Recovery 11G Release 2, 12C Release 1. So all that's left is me to thank you, and hopefully you'll go on the course. So thank you very much.